Hey Valley Middle, welcome back to another G67 math video. Tonight we're going to be working with dilations on the coordinate plane. Let's start off with our trivia question tonight. Who is this guy? He is a character in movies and an actor, a very good one. He's in a series of movies. See if you can figure that out while we're working tonight. Tonight officially our targets are I can use proportions to dilate a geometric figure on a coordinate plane, and I can determine if a dilation on the coordinate plane is an enlargement or a reduction. Let's do this thing. All right, so tonight, square ABCD is shown on the graph below. Draw this image of the figure after a dilation with center A and scale factor 2. Sounds kind of complicated, but let me take you through it. First of all, scale factor 2 and a dilation. Dilation means we're going to enlarge it or reduce it. So a dilation with a scale factor 2, that means we're going to double the size. Okay, now it has a center of A, so that means point A is going to stay fixed. Well, if we double each of these sides here and point A stays fixed, it means we're going to kind of stretch it out like this, right? So you can figure that if point D over here, our new point D, we'll call it D prime, that one would have, if this is at 4, 0, that would have to be over here at 8, 0. And B prime would be up here at 0, 8, right? We could even kind of try to figure out that C would probably be up here. We could kind of sketch it and figure it out. Or we could do any of these points mathematically too. To find those, you just have to take the coordinates, like 4, coordinates for point C here, and you multiply it by the scale factor on each side. So here's 4, my original points, multiply each side of that coordinate pair by the scale factor, and my new point is 8, 8. So now I can click that in, and there you can see my dilation. So I have A prime, B prime, C prime, D prime. That's a dilation of our original ABCD. The scale factor is 2, which is greater than 1, so it's an enlargement. Okay? Now, you might be wondering, well, what if I kept one of the other points fixed? Could I do that? Sure. If you wanted to keep point C fixed, you could dilate it this way. You'd be dragging it down, and it would look something like that. Okay? All right. Math word or dale. Dilation. Enlarging or reducing of a figure. Next, scale factor. That's the ratio of corresponding sides in similar figures. So if you have a scale factor that's greater than 1, as I said, that's an enlargement or a stretching of it. If that scale factor is less than 1, that's a reduction of it or a shrinking of it. So the center of a dilation, that's that fixed point like A was that you use for measuring when altering the size of the figure. So you kind of got to watch out for that when they put that in. So today our job is really twofold. We have to graph some dilations and then determine if those are enlargements or reductions. And some of those questions we'll throw together so you'll get lots of practice. 2 pause problems tonight. Let's go ahead and start with this first one, something simple. Let's just dilate a line segment. So we have to graph this segment B prime S prime as a dilation of segment BS. Now use the scale factor of 1/4. Classify the dilation as an enlargement or a reduction. Well, part of my training tonight here is to get you used to some of this language here. So let's cut through it. We got BS. We have to take and use the scale factor of 1/4 to make a new dilation and then just classify it. So we're going to start off with looking at B and S. B's points or coordinates are 2, 8 and S's are 10, 6. So we got to make a new point B and a new point S. We'll call them B prime and S prime. Take each side of that coordinate pair, multiply it by the scale factor, and you'll have your new coordinate pair. So here's 2 and 8, my original coordinate pair. Multiply each side by 1/4. Our new coordinate pair is right here, 1/2, 2. Do the same thing for S prime. Put in the original coordinates, 10, 6. Multiply each side of the coordinate pair by the scale factor, and then you have your new coordinate pair, 2.5, 1.5. And then you can pop it up here on the graph. You'll notice the slope of the line is the same. It's definitely smaller. That's because it's a reduction. We knew that because that scale factor was 1/4. So I could have classified it right away. You see the scale factor, less than 1, it's in a reduction. Okay? Let's go on and have you try one. Same type of problem. Graph this line segment, A prime, D prime, as a dilation of segment AD. Use a scale factor of 3. Classify the dilation as an enlargement or a reduction. Okay? Wait a minute, before you get all whack on me, you don't have to graph anything tonight. All I'll ask you to do is take these 2 points and come up with the coordinates for A prime, D prime, and I'll do the graphing. Go ahead. All right, let's see how you did. Well, A prime is going to be -1, 2, those are my original coordinates. Just multiply each side of that coordinate pair by the scale factor of 3. My new coordinates would be -3, 6. D prime, do the same thing. Multiply each side of your coordinate pair by the scale factor of 3. Your new coordinate pair is 9, 6. It'll look something like this when I graph it for you. Okay? Again, same slope. Definitely an enlargement, but we knew that. The scale factor was greater than 1. All right. So now we're going to dilate a shape. So here I've taken it off the coordinate grid, and I just threw it on a piece of graph paper. So now we have to draw the image of triangle XYZ. So we're going to draw an image. It means we're going to draw a dilation of this, and we're going to use center of X, and we're going to use a scale factor of 2. So if this is going to stay fixed, you know that it's going to be stretched out kind of like that first one, and that first square we did in this shape, right? So we know Y prime and Z prime are going to be out there someplace, but how do we do it when we don't have any coordinate, we haven't got the numbers on the graph? Well, let's just start off and let's just say that X is 0, 0 then. And X prime would be 0, 0, 2 because it's going to stay fixed. So we can just determine what Y's coordinates are from X. So that's 1, 2, 1, 2, 3. So Y would be 2, 3. Multiply each side of that coordinate pair by our scale factor, and our Y prime is going to be 4, 6 up here. Z originally was 1, 2, 3, 4, 0. Multiply each side of that coordinate pair by the scale factor of 2, and our new coordinate pair for Z prime is 8, 0. I can take and graph those out. And now we have X prime, Y prime, Z prime. That's a dilation. It's definitely an enlargement. We have that scale factor of 2. We know that because that scale factor is larger than 1. Okay? All right, one more type of situation I want to throw at you. Sometimes you have to look at 2 different shapes, like these parallelograms, and decide whether they're an enlargement or a reduction, and you have to figure out the scale factor and do it that way. So let's read the problem. RSTU, down here in black, is a dilation of ABCD. Find the scale factor and then determine if that dilation is a reduction or an enlargement. All right, well, to find the scale factor in something like this, you can just take corresponding points, like we're going to use U and D, and we're going to look at the coordinates, and then we're going to look at the X value, and we're going to put the dilation over the original, and that's going to be our scale factor. Okay, I'm going to take you through it one more time. Corresponding points, U and D. We're going to put the dilation over the original. So U prime over D. Dilation over original. DO, just do it. DO. So U's values are 3, 2.5. Here's my XY. And here's my XY for D. So I've set up my little pair. I'm just going to focus on that X value of each. And that's 3, 6. Simplify that down to 1/2. That's the scale factor. I could have done that for S prime and B as well, or R prime and A. Just make sure that you put the dilation over the original, just focus on the X value, simplify it, that's your scale factor. Okay, so this is the original, this is the pre-image they call it, this is the dilation, it's got a small scale factor, less than 1. Of course, that's a reduction. All right, time for you to try one. VM is a dilation, V prime M prime is a dilation of VM. Find the scale factor and determine if that dilation is a reduction or enlargement. I'm going to go ahead and give you this little dilation over original to help you find the scale factor. Go ahead and pause the video. Okay, let's take a look. Well, dilation over original, so it's M prime over M, and I just took 6, 9 is my M prime, 2, 3 is my original, my M. Look at the X value, 6 over 2. 6 over 2, that simplifies to 3. Put that guy in over here too. Sorry about that. Okay, scale factor is 3. Reduction or enlargement? Well, it's greater than 1, so that's an enlargement. Okay, definitely an enlargement. All right, you're ready for the ticket to the show. I know you've been very patient with me tonight. You're waiting for the answer to that trivia question. So here's what I'm going to have you do. I'm going to have you take a look at this triangle ABC, and I've given you the coordinate points for A, B, and C. I want you to figure out what A prime's coordinates are, B prime's, and C prime's. You don't have to bother graphing it out. We'll do that tomorrow in class. All right, I want you to figure out what those coordinates would be. If this, draw the image of it with a dilation with a scale factor of 2. All right, go ahead and do that for me. Copy those down. Okie dokie, let's go on to the trivia question. Who is this guy? This is Jason Bourne, of the Bourne Identity, the Bourne Supremacy, the Bourne Ultimatum. There was even one called, with this guy, and I think this is the Bourne Legacy. There's another guy who played, this guy down here. He did one of the films, I think it was the Bourne Legacy. So there's actually been 4 Bourne movies. The 5th one is coming out. It's probably out by the time you watch this, but it was kind of interesting. If you've read any of the books, I think it was by Robert Ludlum. Anyway, this name Jason Bourne, the guy has amnesia in the movie, and he forgets who he is, and he's this assassin type of guy. But it says here that the name Bourne came from Ansel Bourne, a preacher in Rhode Island. And it goes on to tell how this preacher one day woke up with like amnesia, and he moved and started a different life for 3 months in Pennsylvania under this name of Brown. And then just one day that he wakes up and he realizes, hey, what the heck am I doing in Pennsylvania? And why am I? So then he went back home. But anyway, they took the name Bourne from this historical character. So as so it said in the cliff notes of the movie. So anyway, I thought that was kind of interesting. Thanks for listening. Have a great evening.